Alright, on the first one, you're just going to set 5y plus 6 equal to 2y plus 21. And then solve that equation. So you get 3y plus 6 equals 21. Subtract 6, so you get 15. And then divide by 3, so y is 5. And on the Google Forms, make sure 5 is the only thing that you actually put in the text box. On the second one, there's two ways to do this problem. I gave you too much information, okay, on purpose. I wanted you to be able to sort through and figure out what you really needed, okay? So measure of angle WYV is 5N. So WYV is that angle. So that whole angle is 5N. So that really means you could say this part plus this part equals the whole thing. So in other words, you could say 3 times n minus 2 plus 58 equals 5n, and then just solve that equation. So that gives you 3n minus 6 plus 58 equals 5n. And so really 3n plus 52 equals 5n. Subtract 3n and then divide by 2. So n equals 26 will be the solution. Now, you could also do it another way. Instead of using the 5n part, you could say angle XYZ is 4n minus 6. So you could also do it like this and say 58 plus 2n minus 12 is equal to 4n minus 6 and solve that equation. So either way will work. Alright? Okay, on the proofs, the first one here, you're given that angle 1 and angle 2 are vertical angles. And if you look at your cheat sheet, vertical angle theorem says if you've got vertical angles, then they're congruent. So that's how I know number 2 is your vertical angles theorem. Number 3, angle 1 and angle 3 are a linear pair. That's a given. And if you look on your cheat sheet, linear pair theorem says if they're a linear pair, then they're supplementary. So that's how I know step 4. If angle 1 and angle 3 are a linear pair, then they're going to add it to be 180. So that's linear pair postular theorem, depending on what book you look at. Okay, so linear pair theorem. Number 5, measure of angle 2 plus measure of angle 3 equals 180. Well, that's almost the same thing we had in step 4. It's just that we changed measure of angle 1 to measure of angle 2. So we use substitution right there. And then step 5 to step 6. Well, we just said in step 5 that their measures out to be 180. So then that means that they're supplementary by definition of supplementary angles. On number 2, we're given that measure of angle 2 is 100 degrees, and we're also given that angle 1 and angle 2 are a linear pair. So how do you know step 3 that the measure of angle 1 plus the measure of angle 2 is 180? That's our linear pair theorem that says if they're a linear pair, then they're supplementary. So in other words, they're going to add it to be 180. So that's our linear pair theorem. And then from step 3 to step 4, all we did was change measure of angle 2 to 100. So that is substitution. And then to go from step 4 to step 5, we subtracted 100 degrees from both sides of the equation. So when you subtract the same amount from both sides of the equation, it's the subtraction POE. All right, on this one, we're given that angle 4 is congruent to angle 5. And then you also know that angle 3 is congruent to angle 4 because those are vertical angles. So that's our vertical angles theorem. And so then we're going to have to use the transitive property. I know it looks like substitution, but this is a congruent symbol. So if it's congruent, you cannot use substitution. It has to be equal sign to be substitution. And for step 1 and step 2, we said that 5 and 3 are both congruent to 4. So if they're congruent to the same thing, then they're congruent to each other. So that is your transitive property. Okay? And then from step 3 to step 4, basically we said that angle 3 is congruent to angle 5, and so their measures are equal. So the only thing really that changed was from congruent to equal. The 3 and the 5 are still the same place, okay? So when you just change from congruent to equal or from equal to congruent, that is definition of congruent angles, okay? It would be definition of congruent segments if you're talking about segments. Now, step 5, if you look at angle 5 and angle 6, look at where they are in the diagram. 5 and 6 form a linear pair. So if they're a linear pair, then I know they're supplementary by the linear pair theorem. And then from step 5 to step 6, we basically just changed the 5 to a 3 And the reason I can change the 5 to a 3 is because up here in step 4, I said they were equal to each other. So I can plug in one for the other one, and that's called substitution. And so now from step 6 to step 7, you've got that measure of angle 3 plus the measure of angle 6 equals 180. So if they add up to be 180, that means they're supplementary. So that's the definition of supplementary angles. All right, and then this one, we're given that 1 and 2 are complementary. Well, what does complementary mean? It means they add up to be 90. So that's step 2. Their measures add up to be 90 by the definition of complementary angles. And then you're given that angle 1 is congruent to angle 3. Well, if you're given that angle 1 is congruent to angle 3 in step 1, or step 3, and then step 4 is basically the only thing that changed was congruent to equal. So again, that's definition of congruent angles. All right, and then from step 2, and I'm going all the way up to step 2 to get to step 5, because those are the ones that look very similar. The only thing that changed was I changed measure of angle 1 to measure of angle 3. And the reason I can do that is because right here in step 4, I said they were equal to each other. So I can plug in one for the other one, and that's called substitution. And then same thing to go from step 5 to step 6, you basically change the 2 to a 4. And how can you do that? Well, back in step 4, you said they were equal to each other, so you can plug in one for the other. Again, that's called substitution. And then to get to step 7, it says angle 3 and angle 4 are complementary. Well, complementary means that they add up to be 90, and that's just what we said in step 6, is that their measures add up to be 90. So that means they're complementary by definition of complementary angles. Okay? All right, and then on this one, we're given that Vx is 1/2 of Vz. And then to go from step 1 to step 2, the letters are the same, but they got rid of the 1/2, and they have a 2 over here. So basically, they just multiplied everything by 2. So they got 2Vx, and then here the 2 and the 1/2 canceled, so they just have Vz. So that's the multiplication property of equality. And I gave you step 3. Step 3 was the distributive property. It's basically the distributive property backward. All right, so it's the distributive property backwards because you break up the 2Vx into Vx plus Vx, okay? And then step 4 is saying Vz, so the whole thing, is equal to Vx plus Xz. So that's part plus part equals whole. So that one is segment addition postulate. All right, now, to get step 5, you see Vx plus Vx, and we also have Vx plus Vx in step 3. So we have the same thing we have in step 3, except that we have changed Vz to this stuff here. So the reason we changed Vz to that stuff here is, again, from step 4, we said Vz is equal to all that stuff. So I can replace Vz with all that stuff, and so then that gives me the equation that I have in step 5. Now, the whole point in doing that is because in step 6, you can just go back to step 5 and subtract off a Vx from both sides. And so then you just have Vx equals Xz. So that is the subtraction property of equality. And now that we've said Vx is equal to Xz, then that means X is in the middle. And that's from our definition of midpoint. All right, step 6, we're given that BC is equal to CD and AB is equal to DE. All right, and we're trying to prove that AC is equal to CE. Well, that looks pretty obvious because if you look at the tick marks, that would be true, okay? So let's look at this. On step 2, they basically took the equation they had here in step 1, that BC is equal to CD, and then they added AB to both sides. So that's the addition property of equality. And then to step 3, all they did was replace BE with DE, so that's substitution. Step 4 is your segment addition postulate, part plus part equals whole. And then to get step 5, well, if you go back to this step, you have BC plus AB. Well, I know from this step, BC plus AB is really equal to AC. So I can replace that with AC. And then over here I have CD plus DE. Well, I just said CD plus DE is equal to CE. So I can replace this with CE. So that gives me the equation AC equals CE. So that is substitution. All right, and the last one. AC is equal to BD, that's a given. And then AB plus BC equals AC, that's segment addition postulate, part plus part equals whole. And then BC plus CD equals BD, again, that is segment addition postulate. Number 4, you have the same thing on both sides, that's your reflexive property. All right, so then step 5, how do we get AB plus BC equals BC plus CD? Well, up here, we say AC equals BD. And so in place of AC, I could really write AB plus BC. And over here, instead of BD, I could write BC plus CD. So that gives me that equation, which is substitution. And then to get step 6, they just subtracted off BC from both sides. And so that's the subtraction property of equality. And now that we've said the lengths are equal, then the segments are congruent by definition of congruent segments.